Hi, everybody. Welcome to tonight's webinar, Free Algebra Regents Review. Good evening, everyone. Hi, my name is Olga. I'm a longtime Kweller Prep tutor. I'm going to be running tonight's webinar. We'll be reviewing a real algebra Regents exam to help prepare you guys for your upcoming Regents exams. This is the third of our 3 webinars for the Regents. We've so far covered chemistry, geometry, and tonight is the last one covering algebra. So welcome to our webinar. I'm going to give everybody a few minutes just to get settled down and have some extra people roll in from the waiting room. And we'll start promptly in like 2 to 3 minutes. So 5:02 or 5:03, you guys could sit tight. I'm super excited to be teaching tonight's webinar, and I'm excited that we get to spend 2 hours together. Hopefully you guys learn a lot.
You're good, Olga?
Yep, we're all good.
Okay. Everyone, I just want to let you know Olga is available for private tutoring. If you decided that you wanted to proceed with individual private lessons, Olga is available for that. So I definitely want to keep that on everybody's radar. Olga, do you want to just discuss your availability while we're getting everyone situated into your class?
Sure. So I'm recently graduated from medical school, so we have this period of time before, like after graduation, but before residency. So I have a nice, good chunk of about 2 months of time that I'd love to dedicate to teaching all of you guys, which is why we're doing these webinars, and I'd love to have private time with you guys as well to help prepare you for all of your upcoming exams.
So just to be super clear, you have 2 months of time right now that would work, and you would be able to offer Zoom lessons, right? Online.
Absolutely.
Great. Do you want to add any subjects that you're especially comfortable with? I think it would be great for the group to know that you are also available for private tutoring,
Of
and
course.
just let them know what subjects.
Of course. So I have experience with all of the Regents examinations, algebra, living environment, chemistry, and geometry, which is why I'm running these webinars. I also have experience with specialized high school exams, so SHSAT and the SAT. So if you guys are preparing for any of those, now is a great time to start, especially in the summer seasons when you guys are off from school.
Great. And that's it. I just want to say thank you to everyone for listening, and Olga, thank you for these excellent reviews and details, and really, truly all the hard work that you do. And that's it. I'm going to log off. I'm very happy that everyone's in the group and in the Zoom, and I hope you all have a wonderful webinar with such a seasoned and trusted teacher at Kweller Prep. All right. Take care, everyone. Have a great lesson.
All right, guys. So with no further ado, we're going to go ahead and get started. All of you guys should be able to see my screen. Like I said, we're reviewing a real life recently released Regents. This is the most recent Algebra 1 Regents exam. So here's what the front page is going to look like. On your real life exam, they'll give you this kind of page with the booklet. I'm sure you guys are familiar with this. And then it'll begin with a multiple choice section of 24 questions, and each of them are worth 2 points. So the very first question that they're throwing at us is a graph question. We have the graph below represents a dog walker's speed during his 30-minute walk around the neighborhood. So what's extremely important whenever you guys are doing a graph question is looking at the axes. So whenever you have a graph question, you must look at the axes. That is how the graph is read. That is what the graph is showing. And your axes are kind of like your, cheat sheet towards what are you actually looking at. So what you're going to see is you have speed, which is, miles per hour, and then you have time, minutes. So what you'll see is that there are 2 units on our y-axis. Do you guys see that? We have miles, and then we have this really, really important word per, and then we have hour. So per always means like over or divide, right? So we have speed, and we have our unit in miles over hour, and then it's the x-axis is time. right? So we've got two time variables. Now, these graphs can get a little bit confusing because what they're asking is what is it showing between the 12 and 18 interval, 12 and 18 minute interval. So obviously you guys are going to go to the 12 to 18 minute interval, right? This word minute tells me that I have to look for this in my x-axis, right? Because my x-axis is minutes. So I'm going to go to my x-axis and I'm going to get to the place they want me to look at, right? 12 to 18. So what do we see at that point? From 12 to 18, what is the line doing? Constant, right? It's staying the same, right? So if I extrapolate back to my y-axis, at 12 minutes, he's walking at 1.5 miles per hour. At 14 minutes, oh, he's still at 1.5 miles per hour. At 16 minutes, he's still at 1.5 miles per hour. And at 18 minutes, he's still at 1.5 miles per hour. So the fact that this line is this horizontal line is telling me that during all those minutes between 12 to 18, it's constantly staying at 1.5 miles per hour. Does that make sense? So the key here is constant rate. And if they wanted you to know what was that constant rate, you would go back to the y-axis like we did, and we would see that that constant rate is 1.5 miles per hour. So this first one is choice 1. Now, just for extra practice, what is happening between minutes 24 and 28? Yeah, decreasing, right? So if I look at 24 to 28 over here, we see that our line is sloping downwards. And again, if we extrapolate the speed, right, here it's at 3, here is at 2, and here it's at 1. So between those times of, 24 and 28 minutes, the speed went from 3 to 2 to 1, so that is decreasing. Eventually, you guys will go further and further and learn about slope. I think you already did, but there's further sort of implications of slope that you guys will learn as you move on in high school. But what I want you to do is connect this graph to the slope, right? So here, the slope is positive or increasing, right? Here, the slope is negative or decreasing, and that matches what's going on with his speed and what's going on with these types of questions where they're asking you that. Okay. Next we have which value of x will make this relation a function? So who can tell me the definition of a function? Yeah, one input for one output. Absolutely. So what does that mean? Yeah, no repeating x numbers. Good. So in general, what a function means is one input for every output, right? So if I make an x, y table out of the values they give me here, right? I'm going to have 0, 2, and then I'm going to have 4, and then I have x. And then on this side, we have 4, 6, 8, and 7. So if you guys look at all the options, right? 0 would make an x value repeat because we already have a 0 in our table. 2 would make an x value repeat because we already have a 2 on the x side of our table. And 4 would make an x value repeat. So the answer here is 6. Now, I also want to introduce you guys, like just start introducing you guys to test taking skills. That's going to help a whole lot when you guys are studying for higher order exams like the SAT. So what you'll notice is even if you forgot what a function was, right? Or if you got confused and you thought it meant no repeating y values and you couldn't figure out an answer, you pick the option that stands out from the rest. So you guys may notice that 0, 2, and 4, they all show up in the x side. 6 is the only one that does not, right? That is the one that is different. So just introducing you guys a little bit to test taking skills. So what we went over for this one is for it to be a function, we learned one input for every output. And we learned no repeating x values. And what if this was graphed? What's a quick way for you guys to be able to test if something is a function if it's graphed? So let me draw you guys a graph. And you tell me, is this a function? No. So there's something called the vertical line test. And if it passes the vertical line test, then it's a function. So this fails the vertical line test because it crosses the vertical line in two places. So something's a function if it only crosses when you draw a vertical line through it in one place. So for example, something like this is a function, right? Anywhere I draw my vertical line, it's always just going to cross in one place. Does that make sense? So this is a function, and this is not a function. And while we're reviewing, what is the opposite way? Like what is, if we don't want the y values to repeat, what kind of function would that make it? Yeah, horizontal line test, absolutely. So there's something called one-to-one functions, which is where the y values also don't repeat. So I'll put that, squeeze that in here, right? None of this is relevant to the question. You guys will see that my style is I tend to over teach you guys because I want to cover concepts that are not, this is just one secure set of questions, but it's not all encompassing everything that they can ask you. So I use these topics to kind of branch out into related spheres and over teach. So there's something called a one-to-one function. That's when there are also no repeating y values. And this would then pass both the vertical line test, because it's a function, and the horizontal line test. So this function actually that they gave you is one-to-one because all the x values are different, which makes it a function, and all the y values are different, which makes it one-to-one. So this is an example of a one-to-one function. Versus this one that I drew for you guys, this is not one-to-one because he would fail the vertical line test, right? There are two y values that repeat, right? That's what makes it a parabola. That's what makes it symmetrical. So parabolas are functions, but they are not one-to-one. All right, guys, quick pause for questions. Is everybody okay with this little function review that we did? You guys are good? All right, moving on to number 3. So we have the Speedy Jet Ski Rental Company charges an insurance fee and an hourly rental fee. The total cost is modeled by the function r of x is 30 plus 40x. Based on this model, which of the following statements is true? Okay, so what you guys will see oftentimes when they give you these kinds of word problems is you'll start noticing patterns repeating. So it says the total cost is modeled, right? So whenever you guys see is, that means equals. So the total cost equals. So if we translate this, this is the total cost equals. Then we have an insurance fee and we have an hourly rental rate. So hourly rental rate, whenever you guys see the word rate, this is always going to be something, a variable, right? It's always going to be expression where you have a constant times x. And the x is always going to represent some form of time, right? In this case, that time is hours because that's how we measure expense of time, right? It's always a rate. So for example, you can rent something for $10 per hour. right? So if I rent it for 1 hour, that's just $10. But if I rent it for $10, that's $100. Or that's the way that like cell phones charge us for the number of minutes that we talk or the number of texts that we send. So whenever you guys see rate, it's always going to be some constant times some X value, and that X value is very often a unit of time. So once you guys understand that concept that's going to repeat over and over again, you'll now understand that this 40x must represent our hourly rental rate. And then that leaves this 30 to be whatever this insurance fee is. And you'll notice that the insurance fee doesn't have any rate attached to it, right? It's just a flat cost. It's just a standard cost. It's just $30 every time. The insurance fee doesn't change based on how many hours you're renting the jet ski for. But the rental rate will change based on how many hours. So now that we have, figured out all the pieces, let's figure out which parts of this is true. So the first one says R of X represents the total cost. That's true. X represents the number of hours rented. Also true, right? I told you guys that it's a unit of time. $40 is the insurance fee. That is not the truth, right? $30 is the insurance fee. And $30 is the hourly rental rate. Again, they flipped it. That's $40. So 3 and 4 are flipped. 1 and 2 are true, which makes our correct answer choice 2. All right, the next one, we have the 11th term of the sequence is. So first, my question to you guys is, what's the pattern here, or what kind of sequence is this? Yeah, it's times -2, right? So anytime that you guys see the word sequence, I want you to think, what kind of sequence is this? And you guys should know 2 types of sequences, right? We have an arithmetic sequence, and then we have a geometric sequence, right? So let's take a second to just review what we know about sequences. Arithmetic and geometric. So what's the difference between these two? So you guys need to know that an arithmetic sequence has a common difference. What that means is that the values are increasing by the same amount every time you're adding, let's say 3, or they're decreasing by the same amount every time you're decreasing, you're subtracting 3. So arithmetic sequences, they have a common difference. You guys must memorize the formula for arithmetic sequences, which looks like this. And I'll dissect all these pieces for you, right? This is your first term, A1. A sub n is the term you're looking for. N is the number of the term you're looking for. And then D finally is our common difference. Now, an geometric sequence like the one we have here, it has a common ratio. So that means things are being multiplied or divided. So when you guys see arithmetic, you should think addition / subtraction. And when you guys see geometric, you should think common ratio, and you should think multiplication or division. And this is the formula for a geometric sequence. So luckily, most of the pieces are the same. So once you guys get comfortable with these notations, like A sub n, A sub I, it makes it like easier because they're similar in both formulas, but they're organized a little bit differently. So again, A sub n, this is the term you're looking for. A sub 1 is our first term. R is our common ratio. And N is the number of the term we're looking for. And I'm just going to highlight our formulas for you guys here. So arithmetic and geometric. So now that we did that little review, let's go back to the question they're asking us. And what kind of ratio, what kind of sequence would you guys classify this one as? Geometric, excellent, right? And the common ratio, I think somebody already said it, is -2, right? That's what we keep multiplying by. So we're now going to plug into the formula. So a sub n stays as a variable. That's what I'm looking for. What's a sub 1? That's our first term. Excellent. That's 3, right? That's our first term. So we plug in 3 for a sub 1. Next is R, which stands for common ratio, which we already said is -2. That's what we keep multiplying by. And then is the exponent is n minus 1. N is the term we're looking for. So we get that from the question. So this is n. So we're going to have 11 minus 1. So we end up with a sub n is equal to 3 times -2 to the 10th power. And then we have to figure out what -2 to the 10th power is. So for this point, you guys could probably, you could use your calculator for this. You don't have to do it in your head. So you just take -2, you'd raise it to the 10th power, and we end up with 1024. And then we have to multiply that by 3. So this ends up being 3 times 1024, and that ends up being 3072. So a few pieces for you guys here of common mistakes that I can predict that some students may make. So you have to remember the formula, first of all. Second of all, you have to remember that it's n minus 1 up here. So you raise it to the 10th power because you see this value would have given you to the 11th power, which is how they want to kind of trick you. So be careful, make sure that you remember that it's n minus 1 in the formula. And that's kind of easy to remember because it's also n minus 1 in the arithmetic formula. And then be careful with your negative signs, right? When you take something like -2 and you raise it to the 10th power, it's an even exponent, right? So -2 times -2 is 4. So the even exponents are always going to be positive, and the odd exponents are always going to end up being negative. So if you type it into your calculator incorrectly and you don't put the -2 in parentheses when you're raising it to the 10th power, you'll make an error. So you see how I wrote it out? Just get into the habit of putting your negatives in parentheses and make sure that when you're inputting it into your calculator, you input it exactly like that. You put parentheses open, -2, parentheses closed, and you raise that to the 10th power. Because if you forget the parentheses, what it does is it just has negative. It takes the 2 to the 10th power, and your negative stays outside of it, which gives you the wrong answer. And then you would end up with a negative option, which is an option here. So those are the places that students would commonly mess up in this question, I would say. Another thing is don't get concerned if you forget the formula, because there is always the opportunity to just, keep multiplying by -2. Just be careful, write it out, make sure that you're doing it the right amount of times to get the 11th term, and not like the 12th term or the 10th term just because you're careless and don't count correctly. But the best way always is to know the formula, because in this case, 11th is not so high of a number, but they could ask you for like the 111th, and you don't have the time to sit there and, keep multiplying by 2 in that way. All right, so those are my little tidbits for arithmetic versus geometric, okay? Next question is asking us about exponential growth. So let's go through these scenarios. Scenario 1 is telling me that Aiden is adding $10 a week to a jar. So $10 every single week. What kind of growth would you guys describe that as? Is that exponential or is that more constant? Linear, right? It's constantly growing by $10 every week, right? It's not growing, the $10 is not changing. Same thing in example 2. A pine tree goes 1.5 feet per year. Every single year, 1.5 feet. Same thing for example 3. Every hour Ella works, she makes $20. The difference in example 4 is that the number of people measuring in computer science doubles every 5 years. So what that means is in the first 5 years, let's say it's 100 people. In the next 5 years, it's going to be 200 people. In the next 5 years, it's going to be 400 people. In the next 5 years, it's going to be 800 people. So you see how this kind of growth, if you were to graph it out, it wouldn't be going, increasing at a constant rate. It would be increasing exponentially. So it would be going up like this, right? It would be going up much, much, much faster because the actual rate is doubling every time versus in all the other situations, these are all linear and they have a constant slope. Okay, next one is asking us about just some simple simplification of algebra. So what I will tell you guys, and I can't say it enough, is be extremely cognizant of this negative sign, right? You must distribute this negative. That is the most common mistake students will make. They'll forget that that negative sign distributes to every single term in the parentheses. Every single term. Be extra, extra, extra careful with subtraction. That's where I see most of my kids making like a silly type of mistake. So this negative sign must distribute to each term. So the 4, instead of being a positive 4, becomes a negative 4. Positive 5 times negative 1, this ends up being negative 5. And then we have negative 2 times negative, this ends up being positive. So I'm going to rewrite this whole thing for us. We have negative x squared plus 3x minus 7. I didn't touch anything on the left side, right? Everything on the left side is staying constant, but the negative is distributing to everything after it. So instead of the positive 4x, we get negative 4x squared. Instead of the positive 5x, I get minus 5x. And instead of the minus 2, I get positive 2. You guys understand what I mean by distribute, right? Pretend there's a negative 1 here, and you're multiplying each of those terms by negative 1. The same way that you would if it wasn't negative 1. If it was negative 2, then you would multiply each term by negative 2. Now, that was the hard part. Once you get that part down, the rest is just like terms. So if you get confused, I like underlining or circling the terms that I'm going to combine together so I just don't get confused. And I have the privilege of using lots of colors here. I love colors, but you guys can also underline in like different types of ways. So you can circle one, you can squiggly the other one to kind of, sort the terms for yourself so you don't mess up what you're adding. And once we do that, then we combine our like terms. And remember, like terms means they have the same variable and they're raised to the same power. So negative x squared and minus 4x squared, those are like terms. That means I can combine them. So negative 4x squared minus 4x squared, I get negative 5x squared. Positive 3x minus 5x, I get minus 2x. And then minus 7 plus 2, I get negative 5. So my final answer ends up being negative 5x squared minus 2x minus 5, which in this case is choice 2. All right, done with the second page. Again, just going to give you guys a minute to finish writing down and see if you guys have any questions, whether they're specifically about these questions or about anything that these concepts are touching on that you want me to do to talk more about or to give you guys extra examples on. Okay, no questions. So we're going to move on to number 7. So number 7, we have f of x equals x squared. Here's the function that we're starting with. And the question is, what happens when I shift f of x 3 units left and 2 units down? So what are the rules for shifting functions? So when I move up and down, which way am I moving? Yeah, you guys can just put it in the chat. So if I want to move side to side, right? If I want to move left and right, I'm gonna use this idea. The new function is gonna look like this. G of x is equal to f x minus h. So what does that mean? So the sign of the function, if h is positive, then the graph is going to shift right. So if h is positive, that means I'm shifting right. If h is negative, that means I'm shifting left, right? So in this case, they want us to move 3 units left. So if I put that in, it's going to be f of x minus -3, right? Negative makes me go left, -3. And these two negatives make a positive. So at this point, I know that this inside my parentheses must be +3 in order to explain my shifting left. Now, what about the other piece? What about the vertical piece? Where does the vertical piece go? Well, the vertical piece goes outside of the parentheses. So the vertical piece looks like g of x is equal to whatever f of x is, and then it's plus a. This is the vertical piece. And the vertical piece, when a is positive, then that is shifting up. And when a is negative, that is shifting down. And in our case, we want to shift 2 units down, so it's going to be -2. So that's where this -2 comes from. So you guys have to memorize that when you're going left and right, that is going inside the parentheses. And if you're moving left, then you're putting a positive value inside your parentheses. And if you're moving right, then you're putting a negative value inside your parentheses. And the other way, up and down, is outside of the parentheses, and down is negative and up is positive. Okay, so we have an equation for the velocity of an object, and they want us to solve for A. So what that means is isolate A. So the name of the game in algebra for isolation, or when you're solving for something, is to keep doing opposite operation, right? So they want us to solve for A. What that means is this has to look like A equals, right? And we can see that from all of our options. All of our options are A equals. And in algebra, whenever we're solving for something, in order to get it alone, we always do opposite operation. So what are we working with? Let me rewrite. So we have v squared is equal to u squared plus 2as. So again, opposite operation, right? I'm going to write it down for us. So I want to get A alone, right? So I have 2 problems. The A is attached to the 2 and to the s by multiplication. So I'm going to have to divide to get rid of those. And the A is also attached by addition to u squared. So by convention, what you guys should always do is you figure out the addition subtraction first, and then you work with multiplication and addition. So the u squared is being added. I need to do the opposite operation. So you ask yourself, what's the opposite of addition? That's subtraction. So in order to get rid of the u squared, I'm going to subtract it. And I can't just subtract it away and it disappears, right? Those are not the rules of algebra. In algebra, you guys will see it's very balanced, right? So whatever you do to one side, you do to the other side. That's what makes it mathematically legal because we're not changing the value, right? We're doing the same thing to both sides. So if I subtract u squared there, I subtract it from the other side of the equal sign. So now I have v squared minus u squared is equal to 2as. So now I want to get a alone, but the a is attached to the 2 and to the s by multiplication. So again, you think, how do I get rid of that? Oh yeah, I have to do opposite operation. Well, what's the opposite of multiplication? That's division. So what we have to do is divide both sides by 2 and by s. And divide both sides by 2 and by s. And here you have to be careful because you have to divide the whole thing by 2 and s, right? So here on this side, we get what we wanted, which is a alone. The 2 and the s are going to cancel. And now we're left with this whole thing on our left side. So now we just find the answer choice for that. And in this case, it's choice 2. Okay, next we have a table question. We have Mrs. Smith's math class surveyed students to determine their favorite flavors of ice cream. The results are here. So it says of the students that preferred chocolate, right? Of the students that preferred chocolate. So that means that I only care about this part of the table. That means that I'm not looking here and here. I don't even have to think about it because the question told me to just look at the kids that like chocolate. And now the question is what percentage of those were seniors? So let's take a second to think about percent, right? Whenever you guys are doing a percent question, percent is always part over whole. That's by definition what percent is, right? Part over whole. So first, what's our whole? Well, our whole is given to us in the question, the students who prefer chocolate. So the students who prefer chocolate are these guys, right? 42 plus 67. All those students are the ones that prefer chocolate. And then we want to know what part of those were seniors. So that's just these guys, right? These are the only ones that prefer chocolate and were seniors. So the 67 goes on top. And like always, the hard part is setting it up. The easy part is solving it. So all you guys have to do is either put this into your calculator or you can solve it by hand. So 42 plus 67 gives me 109. So 67 over 109. Which is 61%. And you guys can estimate a little bit. Of course, you have the calculator, so you can always get the exact answer. But again, I want to start preparing your brain to be really excellent test takers. So when I see 67 over 109, I know automatically that it's about 60%, right? Because I know 60 over 100 is 60%. And this is a little bit higher than 60 and a little bit higher than 109. So I know my answer must be close to 60%. So when I look at the answer choices, I'm pretty comfortable with picking choice 4, right? So I want to push you guys to just start exercising your brain and doing those kinds of things. You'll always double check with the calculator, right? Because you have it and you don't want to make a silly mistake, but just start pushing your brain to exercise that kind of muscle of thinking because it's going to help you guys tremendously because there's certain sections on the SAT that do not allow you to have a calculator and you'll be a better test taker for it. You'll start developing sort of what I call test tuition, where you kind of have a feeling that's the answer just based on looking at the numbers, because your brain starts working out that muscle of calculating without depending, on the calculator. Okay, I'm going to give you guys a second to finish writing, and again, we'll pause for questions. Any of these topics that you guys want me to speak more about, or any question that you guys want me to re-review? Sure, we can practice something like 7 more. Let me give you like a new one. So let's say f of x is equal to 2x plus 3. And let's say I want to shift this graph 4 units left and 7 units up. So why don't you guys practice this one? Okay, so let's review, right? So when we're shifting left and right, for left and right, we replace x with x plus h. And when it's shifting left, the h is positive. And when it's shifting right, the h is negative. When we're going up and down, up or down, we add k. So add k to the entire function. And when we're going up, then k is positive. And when we're going down, then k is negative. So now we put it all together, right? So first, let's move it left. So instead of 2x, we're going to replace x with positive x plus 4 because I'm going left. So it's going to be f of x is equal to 2x plus 4 plus 3. And now we're going to add the component of going up. So when I'm going up, I add positive 7. So now it's going to be f of x is equal to 2x plus 4 plus 3 plus 7. And now that we have all of that, then we just simplify, right? So we can distribute the 2. So we end up with 2x plus 8 plus 3 plus 7. And then that just simplifies to f of x is equal to 2x plus 18. So let's do one more. Let's have the same equation, 2x plus 3. And now I want you guys to shift this 2 units right and 2 units down. So again, to summarize, right, when we're moving left and right, we're adding directly to the x. If we're moving left, then we're adding. If we're moving right, then we're subtracting. And if we're moving up and down, we're adding to the whole function. So up and down goes here, and up is positive and down is negative. Left and right is attached to the x, and left is positive and right is negative. So for this one, I'm moving 2 units right. So I'm going to have 2x minus 2. And then I still have the plus 3. That's part of my original function. And now I'm moving 2 units down. So that's minus 2 to the whole function. And then we just simplify 2x minus 4 plus 3 minus 2. And then that ends up being 2x minus 3. Does this make sense? Are you guys kind of getting it through these examples? So left or right, you're adding directly to the x. Left is positive, right is negative. Up and down, you're adding outside of the function. Up is positive, down is negative. Okay, so let's keep going. So we have f of x, they give us a function. And then they give us a different function for g of x. And they want to know f of 1 minus g of 3. So what does this mean? This means that take x equals 1 and plug it into all the x values in this f function. And then take x equals is 3 and plug it into all the x values in the g function. And then once you have the whole answer from the f function and you have the whole answer from the g function, we subtract them. So let's do f of 1 first. We're going to plug in 1. We're going to replace 1 with every single x value in the g function. So we're going to have 1 squared plus 2 times 1 plus 1. So that's going to be f of 1 is equal to 1 plus 2 plus 1, which adds up to 4. Then we're going to do the same exact thing to the g of x function, but now we're not interested in g of 1, right? Be very careful. The question wants us to do g of 3. So we're going to do g of 3, which is 3 times 3 plus 5. G of 3 is 9 plus 5, which is 14. And then finally, the last part is take f of 1, which is 4, and g of 3, which is 14, and subtract them. So 4 minus 14, and that gives us the final answer of -10. So with these kinds of questions, there's a lot of space for like silly arithmetic mistakes. So make sure that you're not confusing what they want you to plug into each function, right? They want f of 1, so be very careful and alert that you're just plugging in 1 into the f function. And then they want g of 3, so be careful and alert that you're plugging in 3 into the g function. And then finally, be careful the order that you're subtracting in, because if you flip it, you'll notice that you'll end up with 10, and they always conveniently put that as choice 1 because it's the first thing that you guys see, and you're like so eager to finish the question and pick it, and that's very commonly how you make the mistake. So usually what I do, again, to be a good test taker is always just go back to the question once you're finished with the question and make sure that you answer the question they asked. Not your own question, but the question that they asked. Okay, so next we have which function has the largest y-intercept? So what is a y-intercept? Like, how would you define it in your own words? Yeah, so the y-intercept is the value of y when x is 0. In other words, right, when x is 0, we're going to cross the y-axis, right? So basically, it's where your graph crosses the y-axis, if you're looking graphically. So that's graphically. And what about in like an equation like y equals mx plus b in the equation of a line? Which value represents the y-intercept? Yeah, the b, right? So this is my y-intercept. So based on all of this, we can now easily figure out what the y-intercept is in each case. So this is a basic equation of a line, right? It's in that shape already of mx plus b. So my y-intercept here is very easily -1. What's my y-intercept in choice 2? That's also easy. The table, right? We said by definition, it's the value of y when x is 0. So when x is 0, my y-intercept here is 2. Now for the third one, we have to do a tiny bit more work because it's not really an mx plus b form. So technically you have to plug in 0 to figure out what your y-intercept is. So you'll say g of 0 is 0 plus 3, or it's just 3. So here my y-intercept is 3. And then finally, in the last one, we can see graphically it crosses the y-axis at 1, right? So this one is 1. So now we have all the values. be very careful. You want to answer their question, right? Do they want the smallest y-intercept? Do they want the largest? Make sure that you're answering what they want. They want the largest y-intercept, which in this case is 3, which also happens to be choice 3. Okay, and the last one on this page, we're tackling a word problem, which seems to be an inequality type word problem. So we have 2 texting plans are advertised. Text plan A has a monthly fee of $15 with a charge of 0.08 per text. So remember when I told you guys about this word per? Anytime that you see per, this is a rate. Anytime you guys see a rate, it's going to be some constant. In this case, it's 0.8 times a variable, right? Constant times a variable. In this case, our constant is 0.08 and our variable is t because it's 0.088 cents for every text. If you only send 1 text, you're paying 8 cents. If you sent 100 texts, you're paying $8, and so on and so forth. So how would I describe plan A? Well, that's going to be $15 plus this fee of 8 cents per text, right? So constant times variable. Now, same thing for plan B. Plan B has a fee of $3 plus a rate of $12 per text. So here is another rate, but it has a different constant, right? 12 cents, but the variable is the same. The per text part is the same. If T represents a number of text messages, which inequality can be used to show that the cost of plan A, so remember this is A, is less than B. So A less than B. So now we just have to figure out the choice that says what we just figured out. And in this case, that is choice 1. Choice 2 is incorrect because this is greater than, right? So make sure that you're figuring out what they want. They want plan A less. And then choices C, 3 and 4, flip where the variable should be, right? The variable should not be on the constant fee. The variable should be attached to the number that has the per. So the 0.08 should have the t and the 0.12 should have the t. So these are no good. So the biggest thing that you guys can take away from this question is realizing that anytime you have something per something, it's constant times a variable. Those things have to go together, right? So we've seen this several times. We see it in this word problem. We've seen it earlier. If I scroll back to this with the hourly rental rate, right? The 40x, that's very similar, right? It doesn't have the per in it in this case, but it's another way of saying the same thing, right? Because it's $40 per hour. Does that make sense? So if you can reword it in that situation of per, then that's how you know that you're dealing with a rate. And it always stays with constant times that variable. Okay, so let's move on to the next page. So we're on number 13. So 13 is asking us for the equation of the axis of symmetry for this parabola. So what is axis of symmetry? It's kind of what it sounds like, right? So where would I fold this in half to make this symmetrical? So imagine that this was in front of you, right? So we automatically know it cannot be a vertical line, right? If I take this and I fold it across this way, I mean a horizontal line, excuse me. If I fold it across this way, there's no way that it's going to be perfectly symmetrical, right? That doesn't make sense because what's here is not mirrored here, right? So we definitely know it's not going to be a horizontal line. So that means that it's not going to be y equals, right? We're looking for a vertical line because that's the way that this is drawn, and the vertical line has to come perfectly in the middle right here, right? And you see everything is mirrored, right? From here, 1 unit, point, point. From here, like 1.5, point. From here, almost 2 point, right? So it's perfectly symmetrical across that line. So now you guys have to learn that all vertical lines our x equals some constant. And in this case, the constant that we need is -1. So here's our answer, x equals -1. And while we're reviewing that, you should also jot down that all horizontal lines are y equals some constant. And that's why we crossed out choices 3 and 4, because those cannot be our answer, because we're looking for a vertical line. Okay, next one is asking me for the degree of the polynomial. So who can define degree of a polynomial? Another way of saying degree of a polynomial absolutely is the highest exponent. And you guys have to be careful with these because I feel like in algebra, we're very used to them ordering our polynomials from the largest exponents to the smallest, right? Like we're so used to seeing 4x squared plus 2x plus 7, right? That's the convention to put it from largest exponent to smallest, but it doesn't have to be that way. And sometimes they will flip it on purpose to confuse you. So if you look at this carefully, like you might miss that there is this larger exponent all the way at the end. So the degree of our polynomial in this case is 3 because our largest exponent is 3. Does that make sense? So just be cognizant that sometimes that's kind of like a trick that they play. Okay, next one, the product. So we know that in math, product means multiply. So we need to multiply these two polynomials. So we need to multiply x minus 3 times x squared plus 3x plus 9. So this is like an intense distributive property, right? So what you guys have to think about is this x term must multiply by every term here. So you're going to multiply x by x squared, then you're going to multiply x by 3x, and you're going to multiply x by 9. And then the second term, which is negative, and I told you guys be extra, extra, extra careful with your negatives, with your subtractions. You're going to multiply -3 by each term. -3 by x squared, -3 by 3x, and -3 by 9. And then you're going to combine all of these. So there's two different ways that you guys can do this. One is just like, horizontally. That's usually how I do it. So you can just say, x times x squared, that's x cubed, x times 3x. That's 3x squared, x times 9, that's 9x. And then I'm going to do that same thing for the -3. -3 times x squared is -3x squared. -3 times 3x is -9x. And -3 times +9 is -27. Right? So just multiplying across, being very careful not to repeat, not to skip any terms, and being very, very cognizant of that -3 as you're multiplying each term, all of that negative distributes to every single term. And then after you do that part, same as I showed you guys before, I like ordering my like terms. So plus 3x and minus 3x, that's nice and easy. These are going to cancel. Plus 9x minus 9x, again, nice and easy, going to cancel. So we're just left with x cubed minus 27. Now, if this is confusing to you guys, or if they give you like more terms in a polynomial, what I also sometimes like teaching is like a lattice formation. If you guys find that you are constantly messing this up, you can try this technique. So what I do is I rewrite all the terms that I have to multiply. So I made a 3 by 2, right? Because in this case, I have 3 terms on this polynomial and 2 terms in this one. So you can have like x and -3, and then you'll have x squared positive 3x and positive 9, and create this kind of lattice box for yourself. And then you multiply each term by itself, right? So you have x cubed, and then you have 3x squared and 9x, and minus 3x squared and minus 9x and minus 27. And then you can just order all of those, smushing them together, and you'll get the same thing. You don't have to use this format. I just teach it for the kids that do mess these types of things up. Just to have a different technique, and different option available to you. All right, and our very last one on this page So we have a simple algebraic equation where we're going to have to use distributive property, right? So the 2/3 is going to multiply to the 3. When we multiply to the 3, the 3's are going to cancel. So we're going to end up with 2. And then we take the 2/3 and we multiply it by the -2. So we end up with minus 4/3 x is equal to 3/4. And we want to solve for x, right? So like I showed you guys before, we're going to do opposite operation. So attached to the x is the 4/3, right? It's being multiplied by -4/3. And there's also this 2. So first I deal with addition subtraction. I'm going to subtract 2 from both sides. And I'm going to do common denominator, right? So because 3/4 is out of 4, I'm going to convert my 2 into out of 4. So this converts to 8 out of 4. Now I have -4/3 x is equal to -5 out of 4. And now I need to get rid of the -4/3. So I'm going to multiply by the reciprocal. But I'm going to multiply by negative, right? Because it's negative. So times -3/4 times -3/4. Everything cancels out on my left, which is what I wanted. I got x alone. And on my right, I just have 15 over 16. Which leaves me with the answer, which is choice 4 in this case. All right, guys, so leaving again some space for you guys to mull over these questions. Ask me anything about these concepts that's confusing to you. I'll give you guys a minute to finish writing and think about if you have any questions. And we're also about halfway through our webinar, so I always like offering you guys a little break so we can take like a 4 or 5 minute break. And then we'll continue through to finish the multiple choice, and then we'll move on to the second part, which is short answers, okay? So you guys can take a nice stretch, snack, bathroom break, whatever it is that you need, and we'll continue, try to come back by like 6:05, 6:06, okay? All right, guys, let's come back together and finish up our last hour of our webinar together. So we finished this page, so moving on to number 17. So we have f of x is 2x plus 6, and g of x is the absolute value of x. And these are going to be graphed together, and they're asking you for what value of x are these equal. So we've got two options here. One is simply just to graph this, right? And then we can see graphically. Another way is just to algebraically equate them, right? That's what they're telling us to do. So we're going to have 2x plus 6 is equal to absolute value of x, right? Because they're telling me f of x is equal to g of x. So all I'm doing is I'm replacing f of x with what it's equal to, and I'm replacing g of x with what it's equal to. Does that make sense? So now all we have to do is solve it. So what you guys have to realize is when we solve it, we realize that that means x can be, you know, positive, or x can be greater than 0, or x can be negative, or x can be less than 0, right? So we have two situations. We have one where we have 2x plus 6 is just equal to the positive version of x. And then we have another situation where we have 2x plus 6 is equal to the negative version of x. And we have to solve both of these. So I can subtract 2x from both sides like this, and we end up with 6 is equal to negative 3x, divide both sides by negative 3, and we get x is equal to 2. But in this case, this doesn't make any sense, because if we plug it back in, it's not going to give me a negative value. So this is what we call like an extraneous solution. So this one is not true. And then we work on this side, minus 2x, and we end up with 6 is equal to minus x. And here we get x is equal to negative 6. Okay, let me just clear this so we have space for the next one. All right, next one, we have 2x minus 7 is greater than 2.5x plus 3. So what do we do here? It's just a simple inequality, so we just follow the rules of algebra. So we're going to combine like terms on opposite sides, right? So for example, I can add 7 to both sides. And then we have 2x is greater than 2.5x plus 10. Then I can subtract 2.5x on both sides. So now we have negative 0.5x is greater than 10. And personally, I like working with fractions instead of decimals, but it's whatever your preference is. So I'm going to rewrite this as a fraction. And then we can multiply both sides by the reciprocal, right? Which is negative 2 over 1. And we end up with x is less than negative 20. So be really careful. You got to flip the sign here. Anytime we have inequalities and we multiplying or dividing inequality by a negative, you must flip the sign of the inequality. That's why you guys saw in my last step, the sign flipped. So that's the most common place that you guys can mess up for these algebra ones, for these inequality ones. Okay, next one is asking us which expression is equal to this. So let's be really careful and distribute out our exponents, right? So the rule is when this whole thing is in a parentheses and you have the 3 outside, that 3 will distribute to every single term within that parentheses. So the 2 becomes cubed, the x becomes cubed, and the y squared becomes cubed. So this becomes 2 cubed, x cubed, y squared cubed. So this becomes 2 cubed x cubed y to the 6. So choice A works. So at this point, I know that this can't be my answer. Then we try the next one, right? So again, this 3 will only distribute to what's in the parentheses. So the 2 becomes cubed and the x becomes cubed. So we end up with 2 cubed, x cubed, and nothing happens to the y stays the same. And 2 cubed is 8, x cubed is x cubed, and y to the 6 is y to the 6. So B also works. So finally, we just have to check C. Now with C, you're multiplying every single term by every single term, right? So 2 times 4 gives me 8. And then x squared times x gives me x cubed. And y squared times y to the third gives me y to the fifth. So this does not match perfectly. So C does not work. So our correct answer is just choice 1, A and B. So let's take a second to review our exponent rules, right? Since that came up. So when multiplying exponents with the same base, we add the exponent. So for example, let's say we have x cubed times x to the 7th, right? We add the exponents. They have the same base, they're both x, and we add the exponents. That means it's x 3 plus 7, or x to the 10th. So that's one of our basic rules of exponents. When we're multiplying exponents with the same base, we add the exponent. Now, when dividing exponents with the same base, as you guys may guess, we subtract the exponent. So in this case, it's x to the 4th over x to the 7th. So that's x to the 4 minus 7th, or x to the negative 3. Which brings me to my third case of when we have a negative exponent, you reciprocal the base and make the exponent positive. So for example, x to the negative 3, we reciprocal the base. Our base is x, so if we reciprocal it, so instead of x, it becomes 1 over x, and the exponent becomes positive. And then one more rule is when you have an exponent raised to another exponent, you multiply the exponents. So for example, if I have x to the 4th, and that's raised to the 3rd, that's the same thing as x to the 4 times 3, or x to the 12th. Right, so these rules are nice when they're all piecemeal, they're easy to remember, but what happens is we can combine all of them, right? And we can have to simplify something, not as simple and nice. So combination example. So why don't you guys try So try simplifying this. Right, I tried to combine all of the rules that I just gave you. I'll give you guys a second and then I'll do it up on the board for everybody. So what I would start with is I would try to distribute out this, right? So this is the multiplication rule. So this up here ends up being x to the 34th, y to the negative 6th over 4x squared y. Then we can do the subtraction, right? So we can pull out a 1/4 and the x becomes x to the 34th minus 2. And then the y becomes negative 6 minus 1, right? There's an invisible 1 here. So now we end up with 1/4 x to the 32nd, y to the negative 7th. And then we learned for the negative exponents, we can reciprocal and make it positive. So this can now simplify to 1/4 x to the positive 37th, 1 over y to the 7th. And then we can combine it all into one nice fraction. So it's x to the 32nd up top over 4y to the 7th on the bottom. So this was a complicated example. I gave you guys a hard one on purpose, but I wanted to show you how you apply all these different rules all at the same time into one thing to simplify. And you guys have all these rules listed here on the side. Okay, moving on to the next one. It's asking us about interest compounded annually. So we start with $4,000. We deposit $4,000. And then we are earning 3% interest compounded annually. And they want the function to represent that. So we have to review the interest formula, right, for it being compounded annually. So that's A equals P1 plus R to the T power. So P stands for principal, or that's like the original amount that you deposit. And then R stands for the, rate of interest. And this T stands for the time. In this case, it's compounded annually. So the T is, how many years. And now we just plug in what we know, right? So we know that P is 4,000. And then we know we know our rate or our interest rate is 3%. So we can write that as 0.03. And we don't know the amount of time, right? That's going to be our X. So now we just simplify this. So it becomes 4,000, 1.03 to the X power, which is choice 4. So be really careful because some of the choices look very, very similar. So like 3 and 4, or even 1 and 2, like be cognizant with what the operations are, right? So this is principal interest compounded. So it's being multiplied, not added. And make sure that you realize that it's 3%, right? So 1.03, not 1.3, right? I wish that we were all getting 30% of interest a year in our bank accounts, but it's not that high, right? So be very, very cognizant with what you're picking. Okay, any questions on anything on this page? Right, so we will move on. So number 21 is a factoring question. So when we're doing factoring, first thing that I start with is I think, is there a term or a value that I can pull out of every single term? So almost right away, we realize that in this example that they're giving us, each term, right, has an X in it. So obviously I can pull an X out. And again, to be a good test taker, especially when you're doing multiple choice, you can start looking at your answer values, your answer choices, right? And you see that in all your answer choices, any one of them pulls out a negative X. So that kind of tells me that the first step that I should do is I should pull out a negative X. So when I pull out a negative X, on the inside, I'm going to be left with X squared plus 10X. Oh, sorry, minus 10X, right? Because I'm pulling out a negative one, minus 10X, and then minus 24. So again, just be careful when you're pulling out a term. What it really means is that you're dividing each term by X. So when I take a negative X cubed and I divide it by X, I'm left with a positive X squared. When I take a positive 10X squared and I divide it by a negative X, I'm left with a negative 10X. And finally, when I take a positive 24X and I divide it by a negative X, I'm left with a minus 24. So all my signs are correct. And now I have to think, well, how do I factor this? So again, to review factoring, right, we want something that adds to negative 10 and multiplies to negative 24, right? So adds to the term in the middle and multiplies to the last term. So that's going to be minus 6 and minus 10. So we have negative X and X minus 6 and then X minus 4. Right? Adds up to negative 10, negative 6 plus negative 4 is negative 10, and multiplies to positive 24. So now all we have to do is find the matching answer choice, which is choice 2. Okay, going on to the next one, we have when the temperature is 59 degrees Fahrenheit, the speed of sound at sea level is 1,225 kilometers per hour. And we want to convert this into feet per second. Okay, so we need to know a few conversions. If you look at all the answer choices, right, they're not testing that you know the conversion factor. They're just testing that you know how to convert because all of them have the same conversion factors, right? So my sort of hint to this is all your units must cancel out. That's how you know that you're doing it correctly, right? So let me show you what I mean, right? So we're trying to convert from kilometers to feet. So we go, there are 0.62 miles in 1 kilometer, right? So look, 1 kilometer is in the numerator, 1's in the denominator. It's going to cancel out. Then we've got 1 hour up here, 1 hour up here. That's going to cancel out. We've got minutes and minutes. That's going to cancel out. But now look at the problem. We have miles and miles. So the miles don't end up canceling out. And I want my answer to be in feet per second. So I need the feet to be in the numerator. Does that make sense? And in example 1, they're in the denominator. So I know that this does not make sense. The units don't all cancel out. Now, if we look at number 2, kilometer, 1 up top, 1 on the bottom, that cancels. Miles, 1 up top, 1 on the bottom, that cancels. Minutes, 1 on the bottom, 1 on the top, that cancels. An hour, 1 on the bottom, 1 on the top, that cancels. And we're left with feet in our numerator and seconds in our denominator, which is what we wanted. So I know that 2 is my answer. Does that make sense? So again, you don't have to actually know the conversion factors. They're just testing the basic principles that you guys know how to convert. And in order to know that you're converting correctly, all your units have to cancel out and you have to be left with the proper unit in the numerator, which is feet in our case, and the proper unit in the denominator, which is seconds. Okay, next they tell me the zeros of the polynomial function. So what are zeros? This is the value of values of x when y is 0. So when we set these equal to 0, right, we end up with x is 4. I set this equal to 0 and get -2, and I set this equal to 0 and I get 0. So choice 3 is my answer. All the values that I want. Choices 1 and 2, they leave out the 0. And choice 4 flips everything. And then finally, the range or domain of the function. So range is all the values of y, right? So if we imagine what, x minus 4 squared looks like, it's a parabola. And this +1 raises the parabola up to 1. So if we imagine, what this looks like, you're going to have some parabola here, and it's going to look like this. And what that means is that your y value will be 1 and greater. So f of x is greater than or equal to 1. So that's your range. It's all your y values, right? There's never going to be a y value anywhere down here based on what that graph looks like. And this is how you know it's a parabola, because it's x minus 4 squared. And again, you guys have your graphing calculator, so you could also just graph this out and look at it visually. All right, guys, so we're almost there. We're 3/4 of the way done with our webinar. I'm now going to move on to the short answer questions. So we're going to start with our very first one, number 25. So we have all the scores for a student's recent test. Those are given to us. And they want you to create a dot plot to model the data. And then they want you to state the median test. So who can tell me what is a dot plot? So a dot plot is kind of like, it's exactly what it sounds like. It's a plot of dots. And for a number line, we then have to take each score and plot it on the line. So we'll start with 85, and we just put a dot right on 85. And then we keep going, through all the values, right? So the next one is 96, so I put a dot. And notice my technique, right? Right after I draw the dot, I cross them out, right? So that's how you are careful. That's how you do not make a mistake. The next one is 92. The next one is 82. The next one is 90, right? So you draw a dot, you cross it out. That's how you are careful. You don't make a mistake. Now, then we have 90 repeats. So what do we do when it repeats? We just draw a second dot directly above it. So that's the 90. And then we have 88. Then we've got 95. Then we have 85. Again, it repeats. So I'm putting a second one. And then we have 88. Again, that repeats. So I'm putting a second one. 90, repeating again. I'm getting to my third one. 87. 96, 82, 85. Then finally, I'm on my last ones, 92, 96, 85, 92, and 87. So this is all a dot plot is. You just are plotting the values given in the table. Again, the technique, just be careful because there's a lot of space to make like a silly mistake here. And then you can like spot check. So for example, I know that according to my graph, I have 85 4 times. So then I could just double check 1, 2, 3, 4. That checks out. According to my graph, I have 96 3 times. 1, 2, 3, right? That checks out. So you can just spot check, or you can check every single one, whatever you feel comfortable with. And now they're asking us about median. So median means, from least to greatest, and find the one in the middle. So luckily for us, the dot plot kind of put them in order for us. So we can use the dot plot to then figure out what's in the middle, or you can take a second and just rewrite everything, right? So 82, 82, 85, 85, 85, 85, 87, 87, 88, 88, 90, 90, 90, 92, 92, 92, 95, 96, 96, 96, right? So I took my time to rewrite everything, and then I can go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 1, 2, and you see that your median is in the middle of these two, right? When we have an even number, we don't have a direct median. There's no number actually in the middle. We have two numbers in the middle, and we have to get to the middle of those. So the way that you do that is you add them up and you divide by 2. In this case, it's going to be 89. Because 89 is perfectly in the center of 88 and 90. And you didn't have to spend time to write them out. You could also just use your dot plot and say, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and then you see that you're in the middle of 88 and 90, which is 89. So it's up to you. You can rewrite them. You could use your dot plot. You could find the average. You could just think what's in the middle of 88 and 90. There are a lot of options available to you. All right, so that was our first short answers. Again, the way to get these perfectly correct is just to be careful. Now, the next part of this, or another thing that they could do is instead of asking you for a dot plot, they could also ask you for like a box and whisker plot. So you could have done that. But you wouldn't have gotten any points, right? So just be perfectly careful with what you do and what you answer. And make sure that you show your work, and that's going to give you, the credit. So rewriting these kind of shows your work, or jotting something down about your explanation of how you got there shows your work. Okay, next is this question that's asking us whether something is rational or irrational. So what does rational mean? Or what does irrational mean? So by definition, an irrational number is a number that cannot be represented as a simple fraction. So when we look at this expression that they're showing us, we can see that all these roots, they are irrational, right? So radical 3, that is irrational, because there's no way that I can represent radical 3 as a simple fraction. So radical 3 is a non-terminating, non-repeating decimal that cannot be converted to a fraction, right? So non-repeating, non-terminating decimal that cannot be converted to a fraction. So it doesn't matter if we multiply that value by 2, which is rational, or we add 6 to it, which is rational, it's still going to end up as an irrational number. So what they're looking for in this answer is that you demonstrate that you understand what is a rational or irrational number, and that you demonstrate that doing operations to this irrational number is not going to make it rational. So we want a complete, response. So a perfect response would say something like this. It would answer the question. So first you have to say 2 radical 3 plus 6 is irrational because you answer their question, you state, and then the explain part, that's where the because comes in. Because it equals to a non-terminating, non-repeating decimal that cannot be converted to a simple fraction. So this response would give you the full score of 2 points because 1, we answer their question, and then 2, we explain it correctly by demonstrating an understanding of our definition of what is an irrational number. Okay, now moving on to the next one, we have this value. Another thing that you could do here is you could actually compute it and put it into your calculator and say what is that, never ending decimal. So you could say 9.4641 ... is the answer, which is irrational. But make sure that the key to getting the part correct is this part, the non-terminating, non-repeating decimal that cannot be converted to a simple fraction. You have to prove to them that you understand what irrational means. Okay, now they're asking us for average rate of change for the distance traveled between hours 2 and 4. So what we care about is here and here. So average rate of change, what does that mean? So that means slope, right? Slope, which we learn is y over x, or delta y over x, which means change in y over change in x, right? So in our case, we care about the change of y and the change of x between hours 4 and 2. So x is downstairs, right, in my denominator. That's the hours, so 4 minus 2 in my denominator. And miles from home, that's in my numerator. So we go 238 minus 112. And then you just have to simplify this, right? So they want you to show your work. So I would take my my time to actually show the work and do 238 minus 112. And that gives me 126. And then 4 minus 2 is just 2. So this simplifies to 63. And always get into the habit of writing your units. So it's going to be 63 miles per hour. That's my units, right? Because it's miles per hour. They put the x on top, but it's always y over x, right? Miles up top, and then we have hours on the bottom. So just get into the habit of always including your units. And that's all it is for number 27. Just make sure that you're showing your work, and that's going to give you, the full credit. And make sure that you include units, right? They specifically tell you include appropriate units. So if you don't, they would have taken out a point. Okay, moving on to 28. So they want us to graph this equation. So how am I going to graph this equation? What would be your process to graph an equation like this? What can I start with? Like in this form, do I know what my slope is? Do I know what my y-intercept is? We don't, right? So we need to convert it into a form where we do know what our slope is and we do know what our y-intercept is. So that form that you guys should be really familiar with is y equals mx plus b. So what I need to do is I need to solve for y. So again, as you heard me explaining before, the name of the game in algebra is you want to isolate certain variables. And to do that, you always want to do opposite operation. So I want to get y alone. Attached to my y is 2x by addition, and attached to my y is 3 by multiplication. So I want to do opposite operation for each case. To get rid of my 2x, I'm going to subtract. So I subtract 2x. And again, whatever I do to one side, I have to do to the other side. That's what makes it legal in math. And then we have 3y is equal to negative 2x plus 15. Next, I have to get rid of the 3. Again, the 3 is attached by multiplication, so I'm going to do the opposite operation. I'm going to divide everything by 3. So now we got y alone. We end up with y is equal to negative 2/3 x plus 5. Now this looks familiar, right? This looks like equals mx plus b. This looks like something we're used to working with. And this looks like something where I can pull out the slope. So the slope is what in this case? And what is my y-intercept? So this is my m, right? This is my slope. And this is my b, or my y-intercept. All right, so we did all the hard work. Now, how do we actually graph this? Where would you guys start with? What's an easy point for us to start with? So I would recommend starting with the y-intercept, right? Because we know that the y-intercept is when x is 0. So I know that 0, 5 is a point on my line, right? So you guys can either label this if you feel the need to, or you don't have to. But 0, 5, so I know that there's going to be a point here. And after I have one point, I can now just use my slope. So the negative slope means that I can either go down 2 and right 3, or I can go left 2 and up 3, right? That's what this negative 2/3 slope means. So I can go up 3, or I can go left 2, right? 1, 2, and then up 3, 1, 2, 3, and have a point here. And again, I can go the other way. So I can go down 2, 1, 2, sorry, down 3 and right 2. Yeah, I flipped it. The same thing, down 3, right 2, down 3, right 2. So minus 2 over 3. And this is what my graph looks like. And then finally, the last step that you guys have to do is you have to connect the dots. And here's my graph. So again, just to summarize the steps, you guys would convert it into y equals mx plus b. At that point, then you know what the slope is, and you can use your y-intercept as your first point, and then you just follow the slope to get the rest of the points on the graph. And then the next piece says, explain why negative 6, 9 is a solution to the equation. So how do we prove that negative 6, 9 is a solution to our equation? So negative 6, 9, right? We know that this is our x value and this is our y value. And we have our original equation, which is 3y plus 2x is equal to 15. So if negative 6, 9 is a solution, if I plug in negative 6 for x and I plug in 9 for y, then that should work out. So that's what I'm going to do. So I'm going to say, well, 3 times 9 plus 2 times negative 6 should equal 15 if that's a solution. So 27 plus negative 12 should equal 15. And 15 does equal 15. So that is definitely a solution, right? Another way we can do it is we can keep graphing and prove that that line is going to fall, that point is going to fall on our line. Right? I think I messed up this graph a little bit, so I'm just going to redo it. So again, we're starting with 0, 5, 1, 2, 3, 4, 5, and then we're following the slope, right? Negative 2/3. So down 2 over 1, 2, 3. Down 2 over 1, 2, 3. Down 2 over 1, 2, 3. And then the opposite. Up 2 over 1, 2, 3. Up 2 over 1, 2, 3. So another way that you could have answered the second question is you could say, well, it's a solution because it falls on the line, right? And it's right here. This point is negative 6, 9. So instead of proving it algebraically, you could also say that it is a solution because it falls on the line. And you want to show your work, so you can take the extra step and you can, circle it and label it for them. Or another way to do it is just to prove it algebraically. Okay, any questions on this one for graphing it or answering the second part? Okay, then we move on to the next one, which says use the quadratic formula to solve for all values of x. So for this case, we need the quadratic formula. So who has that memorized? Who knows our quadratic formula? You guys need to know your quadratic formula for this test. So our quadratic formula looks like this. It's negative b plus or minus the square root of b squared minus 4ac over 2a. Right? So it looks crazy, but that's our formula. And now we have to be comfortable with what is a, b, and c, right? We have to be really okay with knowing what each one of those pieces mean. So a is the coefficient in front of x squared. B is the coefficient in front of x, and c is our constant. So what I like to do is I like to, write out A equals B equals C equals, and then plug in so I don't make any mistakes. So A is going to be 3. B is negative 2. Again, be really careful when things are negative or positive because that's a really common place for you to make an arithmetic mistake. And then C is negative 6. So now I plug in, right? So we have x, negative, b is already negative 2. So I have negative, negative 2, plus or minus. Whenever you have negatives, get into the habit of putting them in parentheses, right? So negative 2 squared minus 4 times 3 times negative 6. This whole thing over 2 times 3. This is how we set it up. Now let's be really, really careful with simplifying all our negatives. So negative times negative 2, we end up with just positive 2. And now inside here, 2 squared is 4 minus 12 times negative 6 over 6. X equals 2 plus or minus the square root of 4 plus 12 times 6 is 72. And it becomes positive because the negative 12 is negative and the negative 6 is negative. And that whole thing is divided by 6. X is 2 plus or minus radical 76 over 6. So now we have to think about radical 76. How do I split up radical 76? You have to think of the largest perfect square factor of 76, right? So let's think about the perfect squares. Okay, 1 doesn't count. The next one is 2 squared or 4. Is 76 divisible by 4? Yeah, it is, right? So divide 76 by 4. We get radical 4 and radical 19. So now we can keep going. We get x plus or minus x equals 2 plus or minus radical 4, radical 19 over 6. So x equals 2 plus or minus 2 radical 19 over 6. And now we can divide all of our terms by 2. So we end up with 1 plus or minus radical 19 over 3 as our final answer. But be really careful because you can't just leave it like this. You won't get full credit because they specifically want your answer to the nearest hundredth. So what you have to do then is you have to go into your calculator and you have to put in 1 plus radical 19 and then divide that by 3. And then you have to go into your calculator and put 1 minus radical 19 and divide that by 3. And you end up with 2 answers, which are 1.79 and 1.12. And make sure that you round to the point that they're telling you. So to summarize, highlights of this question, you need to know the quadratic formula. Some tips is just rewrite A, B, and C and be super careful and cognizant of your negatives just to not make those arithmetic mistakes. Once you get to the point of simplifying the radical, right, you think of the largest perfect square factors of the radical to simplify it. And it's okay if you don't think of the largest, right? Like let's say we had radical 4 and radical 36, that's fine. You would just keep simplifying the radicals until you got to the most simple one where you can't think of any other perfect squares that fit in. And then make sure that you're answering the question. So they want the answer in the hundredths. So that means that we can't just leave it in this form, in this plus or minus radical form. We have to actually go into the calculator, plug in each option, and round our answers to the nearest hundredth and, present them in that way. Okay, any questions on this one? Okay, moving on to the next question. We have this piecewise function. So that means that for certain values, we listen to one equation. For other values, we listen to another equation. So the function tells me that when it's greater than 3, I listen to this side. And when it's 3 or less, I listen to this side, right? So to translate, this is for greater than 3. And this is for 3 or less. And now they want the value at f of 3. So at f of 3, which one am I listening to? The top one or the bottom one? Bottom. Excellent, right? So all I have to do is I have to plug in 3 to, so f of 3 becomes negative x squared plus 15. Now, whatever you plug in, just get into the habit of putting it in parentheses, whether x is positive or negative, right? Because now look what happens. It's negative 3 squared plus 15, which ends up being negative 9 plus 15, which is just 6. But be careful because if you included the negative into your parentheses, you would have gotten a different answer, right? So only what you're plugging in stays in parentheses. So I'm only plugging in 3, so that's what I'm secluding in parentheses. And the negative distributes to the whole thing. So f of 3 for this function is 6. Okay, I think we have time for one more together. So they want us to basically like complete the square, right? To get it into this form. So the way that we do that is we add b over 2 squared. Yep. So again, in this case, be really cognizant of what A, B, and C mean. So A is your coefficient before x squared, so A is 1. B is -8. And C in this case is positive 41 if we move it to the other side, but it's not as important, right? So let's do B over 2 squared. So that's going to be -8 over 2 squared, which is going to be -4 squared. So we have to add 16 to both sides. So I'm going to have x squared minus 8x is equal to -41. I add 16 to this side. I add 16 to this side. Now we end up with x squared minus 8x plus 16 is equal to -25. And the point of completing the square of that in that way is that now this becomes really easily factorable to just 8 minus 4 squared equals -25. And now we did it, right? It's in the form that they wanted. So this is in the form that they wanted. And this situation or method is called completing the square. And by adding half of the b value squared, you always make sure that that's easily factorable. So if you get to this last point and you're like, I can't think of anything that adds up to my middle term and multiplies to my last term, that's kind of a hint to you that you messed up and you made an arithmetic mistake somewhere, because it should be easily factorable once you get to that form. All right, guys, so I want to pause here. Thank you so much for joining me on this Algebra Regents webinar. I hope that you guys learned a lot. If you have any questions at all, I'm happy to stay later, whether they're questions about any concepts here, any specific questions you want me to redo, anything in general. I have a lot of experience teaching lots of different school levels. And like I mentioned, I recently graduated medical school. So if anybody's like, super young and interested in medicine, I'm happy to answer any questions about that as well. I hope you guys had a good night and learned a lot. If anybody wants me to email them the notes, I would be happy to do that. You guys can, I'm putting my email in the chat, so you can just shoot me an email and be like, hey, I was in your webinar tonight, and I'll reply back with a PDF of the notes. And if you guys want more webinars or private tutoring, please reach out to Ms. Kweller and request them. Thank you so much for joining me. You guys are free to go. Enjoy your night and have a good week. Bye, guys. Thank you for listening in. Have a good night. Bye, everybody. Good luck on your exams.